In this video, we'll be talking about another fundamental concept in RPG games, scaling formulas. These formulas allow you to calculate values like damage, healing, or special effects, and allows you to adapt them to the characteristics of both the attacker and the target. In practice, scaling formulas combine different components, such as attributes and stats, from both the entity that is performing the action and the one that is receiving it, if there is any. And this makes the system very flexible. For example, the damage of an attack can depend on both the attacker's strength and the enemy's defense. And it will allow you to easily test and swap the components for calculating the final value in playtime. So in order to create a scaling formula, we can, as usual, go on create, then on SOAP RPG framework, then we have to dive into scaling, and we see that we have here scaling formula. And there is also the Alt-Shift-S as a shortcut. So let's say we want to create a Dragon Slayer attack, for example, scaling formula. Here in the inspector, we can see that we can assign a base value for the calculation of the final value of this scaling formula. And this can be a fixed value, so for example, 100 base damage, or can also, we can opt for a scaling base value. And this is useful if your skills, for example, your attacks or whatever kind of action you are using the scaling formula for, can level up. So if we opt with this checkbox, we can provide a growth formula that is defining how the base value of the formula varies on the increasing of the levels for such skill we are modeling. So for example, if here we create, as usual, one growth formula and is a Dragon Slayer base damage, for example, and here we also need the max level that we, in the other videos, we'll be using for modeling the maximum level that our hero can reach. We need to swap this out with a custom, for example, util int var, and could be, for example, skills max level. And we could use 3 as a maximum level for the skill. Then we can drag and drop this so that we have only 3 levels for our skills. And we could say that starting from level 1, it will get 10 damage per level. So you can see that it starts with 10 damage at level 1, at level 2 it gets 20, and at level 3 it gets 30. So if we come back on our scaling formula and now we drag and drop this growth formula, we will be using a dynamically calculated damage on the base of the level of the skill. But for simplicity, since this would require other setup, we will stick to the base damage, 100, let's say. And we can now talk about scaling components. So a scaling formula final value is calculated by summing together all the values of each scaling component that we add to the formula. And there are 2 sets of scaling components for each formula. That is one for the self, that is the entity that is performing the action for which we want to calculate the final value, and a set of scaling components for the target of the action. Some action may not have any target. For example, if a healing skill is healing yourself, there will not be any scaling based on a target, because it will be sufficient to define scaling components on self. But instead, if we are performing an attack like this Dragon Slayer attack, we will have a target that is the enemy that we are attacking, and therefore we may want to use some target statistics or attributes in order to calculate the final value. So while in general the self-scaling components are much more common to be used, the target scaling components can depend from skill to skill. Okay, in order to create a scaling component, we can just, as usual, go on our SoapRPG framework on scaling, and we see that under scaling formula we also have the entries for attribute scaling component and stat scaling component. Now, the framework is coming with just these two scaling components already available. There is an interface that you can inherit from in order to define also your own scaling components, so that at that point you will be able to also use other types of scaling components in your scaling formulas. There will be another extension of this framework that will be coming out in the upcoming months. That is SoapRPG Health, that is focusing on managing the health and the damage. And that one, for example, is adding a new scaling component that is the health scaling component, adding you to also define scaling based on missing health, on maximum health, or on current health, and so on. So actually these two components are just already available, but feel free to actually extend the interface and provide new scaling component for your formulas. Anyway, let's start by creating one stat scaling component, and this will be the scaling component that we will be using to define how the attack that we are unleashing scales on the base of our own statistics. So for the self scaling components list. So we can give it a name. So for example, Dragon Slayer self scaling component. You see that here it is asking us for a stat set, and I predefined a couple of attribute and stat sets, so that there are just some standard statistics and some standard attributes that we have already for the sake of this tutorial. So I can drag and drop this standard stat set here, and you see that now we can define the scaling for our Dragon Slayer attack, referring to our own statistics when the attack will be unleashed. So maybe in this case we could just, for the sake of simplicity, define 1, so that we say that the attack will deal damage basing on 100% of the physical attack we have. So if we have 60 physical attack, the attack will deal 60 damage. If we now change this, so we can also obviously say, for example, 2, and this will scale with 200% the value of our physical attack. So for 60 physical attack, it will deal 120 damage. And you can obviously also add the scaling on multiple statistics that can work for example, for skills that are thought for hybrid builds. But let's stick for now, for simplicity, to 100% scaling with the physical attack. And let's head back to our scaling formula. So now that we have a scaling component, we can press on the plus button here, and we can drag and drop our brand new scaling component in this slot. And so now the final value of our Dragon Slayer attack scaling formula for now will be just taking into consideration the value of this scaling component. So for this tutorial, I prepared a little really simple script that is actually making a simulation of an attack. You will just print on the console attack performed, dealt certain amount of damage, and you can see that actually from the code from my reference to the scaling formula, I'm invoking the calculate value method, passing in the self entity core, our entity that is performing the attack, and the target that is receiving the attack. And we are actually saving the result of the calculation of the scaling formula into this damage long variable that we are using later on to print. So if we now head on our player, I attached the perform attack script on our player, and you can see that I also set the target of our attack to this handy enemy titan that I prepared for the tutorial, and you can see that here we are required for the attack of a scaling formula. So if we drag and drop our Dragon Slayer attack scaling formula here, this will be the formula that will be used to calculate the value of the damage of the attack. So already you can see how handy, how comfortable is to have maybe various scaling formulas, and how easy it is to actually swap the logic, the scaling of your attack just by having different scaling formulas here in your assets, and you can just replace them by dragging and drop them into the editor. And if we launch the game and we enter in play mode, and if we now, let's temporarily disable the entity attributes for now, and so that we can stick just for the statistics of our player for simplicity. We can see that our player has 50 physical attack, and if you remember, we configured our scaling formula to have a 100 base damage plus the 100% scaling on the physical attack for our player. So 100 base damage plus 50 physical attack, we should expect 150 damage. And in fact, we can see here that we got our attack logged for 150 damage. Obviously, we can at real time change our statistic, so we can bump it to 100 and re-execute the attack, and we see that now the damage is 200. And now, if we want to also take into consideration the attributes of our entity, I pre-configured a scaling relationship in between the strength and the physical attack. So if we go to the physical attack statistic, we can see that there is an attribute scaling component, Fiat ASC, and if we take a look at this, we see that there is a scaling ratio 1:1, so our player for each point of strength will get also 1 point of physical attack. So if we head back here, now that we enable this, the physical attack will be increased by 20 as our player has 20 of strength. So if we were getting 200 damage, we expect now to get 220, because even if we don't see here the increased physical attack, because these are just the base statistics, in real time, under the hood, he is actually having 120 physical attack. So we can press execute attack, and as we can see, we get 220 damage. Now instead, we want to add some scaling for our Dragon Slayer attack, also using the target scaling components. So let's go and create another one scaling component here, and we can go on create, Super RPG Framework, scaling, and this time maybe we want to use the attribute scaling component, and we can say Dragon Slayer target scaling component. And here this time we are required an attribute set instead, so we can drag and drop the standard attribute set, and maybe we want that the Dragon Slayer move deals the more damage, the higher the constitution of the target is. So the bigger the beast, the higher the damage. So we can say that we also want, for simplicity, always have that for each point of constitution we deal 1 extra damage to our target, 1:1 ratio. And we now head to our scaling formula. We press the plus button to add a new scaling component under the target list this time, and we drag the target scaling component we just created. Now our scaling formula will, on top of 100 base damage and on the scaling component for our statistics of the player, will also take into consideration the attributes that the target has. So if we take a quick look at our Titan, we see that he has a high constitution, is very big, 100 of constitution, so we expect the damage of the attack to be increased by 100, as we defined a 1:1 ratio for the scaling component. So we can head back to our player. We can execute an attack, and as you can see, we are now dealing 320 damage. So we're taking into consideration the constitution of the Titan. And if we obviously make it even bigger, 200, and we once again press execute attack, the damage changes. Now, I would like to highlight the fact that we managed to change our scaling formula, also create a new objects in our assets, like the new Dragon's Lair target scaling component, without exiting the play mode. So we managed to change the logic of our attack, how the damage is calculated, without even having to exit from the play mode and enter again, and obviously also without recompiling any script. So this is showing how powerful the framework is with respect to boosting the life cycle of testability, because now you can easily debug real time your game by swapping in and out components, scriptable objects, and seeing the effects in real time without having to stop, exit play mode, recompile, enter again, giving a lot of flexibility in all the process of debugging. And obviously, this is also improving the modularity of your game that you're building, as you can just have your objects here, drag and drop them to any other object. Most of the changes usually don't even require to exit from the play mode, so that you can really have a seamless experience while implementing your game without having to struggle to reload the scene or exit and re-enter play mode in order for the changes to take effect.